Hello, thanks for the introduction. I am indeed Eero Laaksonen. I come from Finland, that explains the name. But how about you guys? I'd like to ask a few questions related to notebooks. How many here use notebooks today? All right, almost everybody. The rest probably don't actually work. They do some sort of management or something. So notebooks started 5 years ago. So Jupyter Notebooks was founded, I think 2015, 5 years ago, and it has pretty much 100% penetration in the data science market. That's pretty amazing, right? Being such a new technology, adopted in such a vast way, there's probably going to be some problems. And I think that I've talked to a few of you, and I think that at least a few of you have run into these problems, especially when going from just basic exploration into more productionized environments. Notebooks tend to be a little bit tricky. And I'm going to be talking a little bit about sort of that environment and how we can start to approach notebooks in a better way. And that leads us into version control for Jupyter Notebooks and asynchronous workflows and so on. All right, so I'm going to be talking about 3 problems that I think and that our company thinks are key problems in notebooks for more productionized workflows. First of all, version control. I've seen quite a lot of examples. I don't know if you can see the text, but here's our, hello. Yeah. So here's a comic that we give out. A lot of people can relate. There's a guy coming to the office, handing in his laptop. Sorry, I got an offer from Google. They're going to pay me triple what you do. I'm going home. I'm there now. And then the boss is like, oh, okay, can we do a handover? And the data scientist is like, sure, everything is on the computer. And then you look at the desktop and you have best model _ old Jupyter notebook. And I'm like, really? Is this it? So essentially you have no idea what other people are doing and how models are actually built. All right, why is this? When we look at software development, we've already sort of figured out these ways of working in larger teams and how we can actually move faster with the bigger bunch of people. But the difference with machine learning is that when we're version controlling stuff in software development, we're talking about code and dependencies. And we've gotten pretty good at understanding how to run code and dependencies in production environments. However, machine learning introduces a few new key aspects. First of all, data. You're not just running code, you're running code that interacts with data, and the end result, the model, is an output of the code. It's not actual code. Then on top of that, there's parameters that go in, so like hyperparameters. And then also there's some key metrics, usually like accuracy, loss, stuff like that you're usually quite interested about. And this extra stuff doesn't really work very well with the software development paradigm that we already have in existence. The reason why this is so different is that we're not tracking actually code, we're tracking experiments. So it can be the same code that we run over and over and over again with different hyperparameters of different data sets. So it's a completely different kind of problem. All right. Second thing, asynchronous workflows. How many of you have been lucky enough to have seen code compiling? There's just a few hands here. All right. So how many of you have had a cup of coffee or, well, YouTube didn't really exist when we used to compile code actually, but did something, maybe had a sword fight like XKCD kind of thing while code was compiling. Do you think that somebody would allow that today in a software development environment? No. That's why we have stuff like Python, so that it's super fast to do stuff. UI development went into web because it's just pressing F5 and things are really fast. We can actually work with stuff and spend the time that we're actually working on things. Well, software development today looks a lot like this. You're running code, you're running tests, but the tests take a really, really short amount of time. However, machine learning looks a lot like this. And now if you think that you're allowed to work like this, spending most of your time having sword fights or Nerf gun fights in the next 10 years, it's probably not going to happen. Like somebody's going to stop this from happening and make you be more productive. Sorry, but it's going to happen. And all in all, if we look at progress in machine learning, I think that it's a very iterative process, and this old quote really rings through. I think it's pretty much like how many experiments can you run in a certain fixed amount of time is a pretty good idea of progress. So what we've envisioned machine learning looking like in the future is probably something more like this, where you can concentrate on working on your code, but push your executions into somewhere where it's going to be executing while you can, again, work on your code. But this is, of course, very complicated, requires really good tooling to achieve something like this. All right, problem number 3. The void, I call it. There's no formal name for this. What I mean by the void is, you already, by the way, saw this in a different context. I'm like, somebody really stole my thunder. Like, it's unfair. But when you build notebooks, you write notebooks, and then somehow something should happen in between, and then eventually you have profit with models in production. But there's this huge gap of, I have this horrible thing that no engineer wants to look at, that can generate revenue or some sort of new product or whatever valuable, but it doesn't really fit the software development paradigm that we're used to in production environments. I think that the key problems why this is have been, has anybody seen this Joel Grew's I Don't Like Notebooks? It was a slide set that, yeah, how many have seen it? Okay, you definitely have to check it out if you're working with notebooks. It really goes very deeply into sort of reasons why notebooks tend to be really hard in production environments. But if you really look at it, I think the key problem that he also looks at, this is like 140 slides or something. So I'm gonna condense it into one. And it's right here. We have cell number 1 saying x is 1, cell number 2 saying x is 2, and then printing x, it's 1. I come from a software development background, and this looks really bad. Like, I don't like it. So state is very dangerous when you're building software, especially if you let it like run your whole code. If you're working really heavily around state, it can end up in pretty problematic situations where you have no way of actually replicating whatever you built. So these 3 problems in mind, we went out and tried to build something that would solve these at least to a certain extent. So what will follow is a shameless plug. You can, but whatever we talked about here does and can be done and solved in many kind of ways. I'm going to show you one, the way that we have started solving it. Let's see. Okay, can we switch over to my laptop and really hope that I don't get any notifications from my friends? I usually do like extend screen, but because I don't have any monitor here, it's going to be really hard. Okay, I have a notebook here. We can execute these cells, but what we've built is a plugin that plugs in to Jupyter Notebooks and gives you superpowers. So you can click this button and click Create Execution. And what we do with Valohai is we take your notebook, we spin up a machine somewhere. It can be your local compute cluster. It can be AWS, Azure, Google Cloud. We deploy a Docker image. We ingest your code. We ingest your data and start running. you can see all of your ongoing executions here. My previous executions that have gone through. And if I want to take and run another one, so going back to those asynchronous workflows, I can spin up multiple runs at the same time. And if I want to, I can go back into the notebook once it's executed. So this run got done. I can click here, and it will pull back the executed notebook, and I can see all of my output here. So that's the asynchronous part. We also version this, so it becomes a sort of a new type of versioning your work. You can also share it with colleagues, so I can take any of these and I can jump on the main side of Valohai, our graphical user interface, where I have everything saved, all the output artifacts that you might want to save. Like for instance, here we're saving the model, are automatically saved behind this execution. And we have all of those dependencies we talked about. We have the code, we have the environment as a Docker image, we have data that went in, we have the hyperparameters and so on. And then lastly, because we parameterize all of this, so if we go and look back at this notebook, this is actually, if you're familiar with Papermill and what Netflix is doing, I recommend you looking into it if you're trying to run notebooks in at least going towards production. So we're defining inputs, which are the data inputs for this, and then we're defining whatever parameters we're using here. We're just doing hyperparameters. We could also parameterize other stuff. So we can have them here. So now these notebooks become sort of atomic functions that we can actually plug into some sort of like execution pipelines, for instance. You could have this step, and especially with here with Valohai, if I want to rerun this, I can just click copy. I could point to a new data set, for instance, if I wanted to execute the same thing over and over again. So it's complete reproducibility. And that helps a lot with the sort of void problem, because these are reproducible. You can actually take it as an engineer. If you're like the previous speaker talked about data scientists and data engineers or machine learning engineers. So we have these titles, so many. Nobody really knows what they are, but usually data scientists do exploration and then throw it to engineers who then build some sort of production environment. It's really hard for an engineer to understand what's going on here and start building that into the production environment. And if we talk about the state problem, you're still allowed to work around state, with state, while executing this notebook, but we give this sort of superpower to data scientists where they can execute the whole thing on larger compute, which naturally ends up into better code because you end up running the whole notebook and you're not so sort of tied down to what you're doing right there and just jumping between cells for the whole day and ending with cells that have a 2,000 number count on them or something like that. All right, that's it. Thank you. Any questions? Oh, the questions are coming. There are questions.
Oh. No, sorry, not right now.
There are no questions.
Not right now. Well, there's one that's coming in. So.
There's one that's coming in. KB.
Does plugin support Jupyter Lab?
Not today, not natively. It would be pretty trivial to fork it for Jupyter Lab. But most of the users that we have today have just jumped off of Jupyter Lab because what this provides is sort of a better way to do things than Jupyter Lab in some sense, for at least for the sort of compute orchestration and sharing. We got another one?
I think so. Yeah, I think one's coming in. We have a minute. You okay?
Yeah.
Okay. Thank you for all of your questions, by the way. We really appreciate it.
Several people are fiercely typing.
They need to know.
Yeah. Pretty sure it's just gonna be get off the stage.
I don't think so.
Caitlin is gonna be like, it's my turn already.
Okay. Which one do you wanna?
Okay.
There's 3 here.
Any thought on Netflix's use of notebooks for production? Well, so I actually know the team quite well. I'm based in San Francisco, and we do some quite a lot of like idea sharing with them. The first time I met them and heard about their sort of idea on running notebooks in production, I was like, you guys are mad. Don't do it. But then, this was already like 3 years ago, I think, or something, 3 years ago, something like that. They had really aspirational thoughts on how to integrate this into the process. And they've made it work. Like, it works very well. They work at the largest scale that there is. So, I don't know. I think they're doing cool stuff. Yeah, I think it's worth looking into.
Regarding version control, how do you handle code review?
So this for versioning is more to version your work and maybe like share ideas. We do recommend using something like Git on top of it for actual commits. So it wouldn't be a tool for code review type of things. But it's a great question. It's very complicated. It's a complicated topic. But we don't want to. So we also integrate with Git and sort of really encourage the Git type of like pull request type of workflow. And I think that Git is going to deploy new proper tools for notebooks that are going to be better. And I think that's going to be the way that code review and stuff is going to work in the future. Right now it's a little bit iffy, but I think that's probably going to be the best practice in the near future.
Awesome. I think this is a good one to end on. There are several other questions that you might want to follow up on, but people want kind of your elevator pitch on what Valohai is.
What is Valohai? I think there's 2 answers to that. Valohai is Finnish and it means lantern shark, which is a deep-dwelling, self-illuminating shark. Valohai is an MLOps platform. This is the sort of exploratory part that you saw. We can then, what we do is from that you can go into actual productionalized pipelines, automate your training, do all the version controlling, model lineage, stuff like that. Deploy models to REST APIs on Kubernetes. We automate like all of that process going from here. That's what Valohai is. Thank you so much.